I'm going to have 4 here. And that's why when you double the amount of total pieces, then you're going to double the amount that you have, or the amount shaded in, or the amount that that person took, or whatever, to find the equivalent fraction. A lot of people are thinking, well, I timesed by 2, so it must be a much bigger fraction. No, it's only going to be a bigger fraction if you only do it to one of them. And I'll show that to you after this example, after I go over 2/3. Okay? And then 2/3 into eighths. Well, 3 times nothing equals eighths, so that's not going to work either. How about 2/3 equal with the tenths? I don't think we ever found a match. Now it's all of a mess, but I remember we didn't find any close match. So that's not going to work either. How about 2/3 equal with the twelfths? Well, I know 3 times 4 equals 12, so 2 times 4 is going to be 8. And if you look over here, I had 8 twelfths lined up neatly. 1 12, 2 12, 3 12, 4 12, 5 12, 6 12, 7 12, 8 12 equals 2/3. Perfect. So if you notice, I had thirds and now I have twelfths, and we said it works by timesing it by 4. So when you quadruple the number of pieces, see how there's 4 here? So when you times the amount by 4, then your top number, the amount shaded or the amount taken or whatever you're explaining, also has to be times 4. Okay, so let's look at another example. List a fraction or fractions equal to 3/4. To save time, I went ahead and figured it out. Okay, so here is 3/4, 1/4, 2/4, 3/4. And I found out that 1/8 plus 1, 2, 3, 4, 5, 6 eighths is equal to 3/4, and 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths is also equal to 3/4. So I'm going to do those 2 examples right here. We know that 6 eighths is equal to 3/4, and we know that 9 twelfths is equal to 3/4. Now, let's say we didn't have the manipulatives. Let's say we were just asked, prove that these are equal. I could say, well, when I double the number of pieces here, and I double the number here, 4 times 2 is 8, and 3 times 2 is 6. So yes, that works. Over here, when I triple the number of pieces, and I triple, obviously you have to triple the amount up here, that works too, so you know they're equal. So I explained in the previous example that a lot of people think, or sometimes students might get confused and think, well, I'm multiplying, doesn't that mean my fraction's getting bigger? And then how does that make it equal? It only will get bigger, the value will be different if you only multiply one part. Over here, you're just saying, hey, I'm going to just double the number of my pieces. Well, if you're going to double the number of your pieces, then you're also doubling the amount shaded. So if I had 3/4, I had fourths, now I have eighths. So 4 times 2 is 8. And I have 3 of them, so instead of 3 here, I have 1, 2, 3, 4, 5, 6. So if you did something like 3/4, what is the equivalent when it's eighths? And let's say you just do this and you left that the same, then your fraction is not equal. I'm going to show you 3/8 compared to 3/4. Let's just move that real quick. This is 3/8. And this is 3/4. As you can see, they're not equivalent fractions. So in this situation, when you doubled here, it didn't work here. You didn't do it here, and so you didn't get your equivalent fraction. Let's look at the twelfths. Suppose, let's go ahead and push these up so we can see. Suppose we said 3/4 is equal to how many when it's 12ths? Well, that's times 3. I have to do it to the top if I want equivalent fraction, but if I, for some reason, don't, then this is, and you're claiming 3/4 is equal to 3/12. Well, when you just have 3/12, that doesn't work. Okay, so let's see if we can answer some of these questions. It wants to know if these are equal or unequal. So it says, is half equal to 3/6? So in the circle, I'm going to have to either write equal, the equal sign, like that. I don't know if you can see. Or the unequal sign, which is this with the line through it. Now, I've told my scholars that you have to write them separately over here and do the multiplication process, because if you do it here, then you're writing in the circle and you need to write your answer. So you might want to rewrite them over here. So that's what I did with all of these. So half, is it equal? So I want you to press pause and see if you can figure it out. Okay, let's go over these now. The first one, 1/2, is it equal or unequal to 3/6? So you can say, well, 2 times 3 equals 6. So that means, is 1 times 3 equal 3? That is true. So then you know they're equal. Let me just show you another way how you can do this. You don't always have to start with the denominator and see what times this will equal that. You can start at the top and say, is 1 times 3 equals 3, so is 2 times 3 equals 6. Both ways it works. So they're equal. And here is a visual for you to see that 3/6 is equal to half. Let's look at the next one. 1/4, is it equal to 2/8? So you can say, well, 4 times 2 equals 8, and 1 times 2 equals 2. So they are equal. Or you can start with the numerator. I know 1 times 2 equals 2. 4 times 2 equals 8. Here is the visual for you to see. The reason why we did times 2 is because we doubled the number of pieces. Okay, let's do the next one. 1/5, is it equal to 3/10? So let's look at 5, whoops. Let's start from the top. 1 times 3 equals 3, but 5 times 3 actually equals 15. So in this situation, they are not equal. We couldn't set up an equivalent fraction. But let's also try it the other way. 1/5, is it equal to 3/10? 5 times 2 equals 10. 1 times 2 equals 2, which means 1/5 is actually equivalent to 2/10. So evidence to show why they're not equal is you can cross out the 3 and just show that it's actually 2/10. And here's the visual for you to see that this is what they were asking us. Is 1/5 equal to 3/10? And we know, based on our multiplication, it's actually equal to 2/10. Let's look at the last one. 1/4, is it equal to 4/12? Well, 4 times 3 equals 12. 1 times 3 equals 3. So this tells us 1/4 is actually equal to 3/12, and that it doesn't work. You can also start from the top. 1 times 4 equals 4. 4 times 4 equals 16. So this is another equivalent fraction that equals to 1/4. So for evidence, you can either cross it out and say 3/12 is equal to 1/4, or you could cross out the 12 and say 4/16 is actually equal to 1/4. So I wanted to go over equivalent fractions also using pictures so you can kind of see the equivalent part of it. So let's just use a simple example that I've used in other ones. 1/2. You can tell this is 1/2 because it's cut right down the middle. So if I had fourths, I would shade in 2 out of 4. And we talked about earlier that the setup, it's times 2 times 2. Let's look at this one. If I had sixths, I would have to shade in 1, 2, 3 out of 1, 2, 3, 4, 5, 6 to equal half. So if I had half is equivalent to 3/6, I would have to do times 3 times 3 because I tripled the number of pieces. Here there were 2, here there are 6. 2 times 3 equals 6. 1 is shaded in. 1 times 3 equals 3. Let's look at this one. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in tenths, I'd have to shade in 1, 2, 3, 4, 5 pieces. To show that half is equal to tenths, I would have to do times 5 times 5. So I went from 2 pieces to 10 pieces, and that's where the times 5 comes in. How about this one? This is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 pieces. 1/2 is equal to 4/8 times 4 times 4. Now if you look at this one, this is fifths. And there's really no way to shade in half. I mean, the best I can do is 2/5, but if I do 3/5, it's too much. So if you were asked to find the equivalency, 2 times nothing equals 5. So it actually not equal. Look at the thirds. I can't shade in half. That's the best I can do. So if someone asked, is half equal to 1/3? 2 times nothing equals 3, so not equal. I hope that explains equivalent fractions.